Hey guys and gals, I hope everyone had a nice spring break. We are starting our second unit in 7th grade. Only one more unit to go after this one, so I know you guys are going to continue doing the great job I've seen you do this year. So what are we going to talk about? We're going to talk about the difference between an expression and an equation. So an expression does not have an equal sign, so it could simply be like 2 plus 3. Or it could be 2x plus 3y. All right, so a couple of different things going on here. We have multiplication, and then we have the sum of these two terms. Now, an equation, though, has an equal sign, okay? So if I said 2x plus 4 equals 14, now this is an equation. Equations have equal signs. Expressions do not have equal signs, okay? That's what you need to remember. So take notes as you're watching my video, okay? All right, so are these expressions or equations? What about the first one? That's an expression. There's no equal sign. The second one, an expression. The third one, I see an equal sign, so that one is an equation. The next one is an expression. The next one, 25 equals, so that's an equation. And now we have this long expression. So there's some terms that I need you to know the definition of. So make sure you're taking notes as we go through. All right. So we're going to talk about each one of these terms down here. Well, the first one is actually the word term. But when we're talking about a math term, basically you need to know that terms are separated by plus and minus signs. Okay. So this is the first term. Negative 5c is the first term. And then there's a plus sign. So it separates the first and second term. The second term is positive 7y. I see a plus sign. So the third term is positive 6. So even though plus and minus signs separate them, they actually apply to that term, or they are part of it, okay? For example, the next one is I see a minus sign, so it separates 6 from the next term, which is actually minus b or negative b, either one of those, whichever way you want to say it. And then the last term is positive 2x squared. So we have 1, 2, 3, 4, 5 terms. An exponent, I believe you're all very familiar with an exponent. If I said, what is 3 squared? That means I want you to multiply 3 times 3. So our exponent is that little number. And so the only exponent we have in this expression is the 2. A coefficient is the number multiplied by a variable. Number multiplied by a variable. Now, what is a variable? A variable is a letter that represents an unknown value. In math, a variable is a letter that represents an unknown value. So a coefficient is the number that's multiplied by a variable, okay? So for example, let's look at each of our terms up here. Our first coefficient is negative 5. Negative 5 is being multiplied by the variable c. The second term, our coefficient is 7 because 7 is being multiplied by the variable y. 6 is not a coefficient because it's not multiplied by a variable. Look at this one, however. What is the coefficient of b? Well, the only thing I can multiply b by to get negative b is negative 1. Negative 1 times b, it equals negative b. Negative 1b or just negative b. So the coefficient of this term is negative 1. And then the coefficient of the last term is positive 2. All right. So our variables are the letters c, y, and x. C, y, and x. A constant is a number not multiplied by a variable. So there's only one number in our expression that's not multiplied by a variable, and that is the number 6. Positive 6 is our constant. And then like terms, we're going to talk about more in just a minute, but basically a like term has the same variable, the same letter raised to the same exponent. And like I said, we'll get back to that one. All right, so, oh, I got a little bit more down here in the corner. Let's say, oh, here it goes. The coefficient of y is 1. So remember, a coefficient is a number multiplied by a variable. So the coefficient of y is 1, and the coefficient of negative y is -1. You need to write that down. You need to remember that. All right, so here we have another expression. How many terms are in the expression? So the terms are 1, 2, 3, 4. We have 4 terms. What is the exponent? The only exponent I see is a 2, the only exponent. And 4x squared means 4 times x times x. It doesn't mean 4x times 4x. If it was 4x squared like this, it would mean 4x times 4x. But the way this is written, only the x is being squared. What are the coefficients? So what are the numbers being multiplied by variables? So the first coefficient is 4. The second coefficient is +3. The third, what is the coefficient of negative z? -1. And that's the only coefficients we have. There's only one constant. A constant is a number not multiplied by a variable, so our only constant is 6. What are the variables? The variables are x, y, and z. All right, so now we're going to get into word phrases that represent these different things on the top, these different operations: add, subtract, multiply, or divide, and then variable and exponent. So let's put these words or word phrases in their place. An unknown number. If we don't know an unknown number in math, it is a variable, an unknown number. All right, what about doubled? If you double a number, it means you're multiplying it by 2. Doubled goes up there. Increased by 7, increased by 3. That means you are going to add. Increased by. Squared, if I say what's 3 squared, I'm looking for an exponent of 2. So squared goes there. What if I said half? What's half of 10? That means you're dividing it. You're dividing a number by 2 if you see the word half. Product, the product of 4 and 5. That means we are going to multiply 4 and 5. Where is multiplication? Okay, product. Next one is, come on, cubed. If I said, what is 5 cubed? I need an exponent, don't I? Decreased by 5, decreased by 2. Decreased by would be subtraction. So decreased by. The next one is more than 4, more than 5. That's going to be addition. More than. Quotient, the quotient of 20 and 2. That means we are dividing. Quotient means division. What else? Total. The total of 5 and 3 is 8. We are adding. Some number plus 5. Some number is, we're going to use a variable to represent an unknown number. Power. If I say 2 raised to the power of 4, 2 raised to the power of 4, that means I need an exponent. Sum, the sum of 2 numbers is addition. You are going to add those 2 numbers, and difference means subtraction. Okay, I think we got them all. All right, so show and multiplication. So now that we're going to start using variables, you do not need to make x's to show multiplication anymore, okay? Because you don't want to use x's to show multiplication and variables as well, because that's confusing. So if you see this expression 5 times a number, you could either show it with a dot, 5 dot x means 5 times x. You can use parentheses around one or both of those two things. You could either put parentheses around just the x or around both 5 and x, or you can just squish together a number with a variable, and 5x means literally 5 times x. The product of 3 and a number, 3 dot x. Here's our parentheses, and this is using no symbols. Some number multiplied by 4. Some number multiplied by 4. We have our examples there. How would I write the product of 5 and the quantity of 4x plus 3? If you see quantity of, that means all of this that's written after quantity of has to stay together, which most of the time that means you have to put parentheses of them around them. So the quantity of 4x plus 3 is this. So basically it's 5 times all of this, and that's the way you write it. If you simply write 5 times 4x plus 5, that is incorrect, because the way it's written, you would only multiply 5 by 4x, not the quantity of 4x plus 3. So this is the correct way to write that. All right, let me get rid of that. The sum of an unknown number and 6, comma, times 5. That means everything in front of the comma stays together, and whatever's after the comma you do to the whole thing, So the sum of an unknown number, so sum is addition, an unknown number is a variable, x plus 6, all of that, comma, times 5. Once again, you must use parentheses to show that this whole quantity is being multiplied by 5. Now, there's a couple that is very important to write in correct order. So if you are subtracting, if I said, what is 5 minus 2? Does that equal the same as 2 minus 5? No, this is 3 and this is negative 3. So when you're subtracting, the order of the numbers matter a lot. And so this expression less than is a tricky one, because you actually are going to flip the order of the numbers written in a word phrase. Let me show you what I mean. 10 less than a number, 10 less than a number. Less than means you're going to flip whatever's in front to the back and whatever's in the back to the front. So a number minus 10. This is how you write 10 less than a number. Whatever's in the front goes to back. All right. Order matters. All right, what about the next one? The quotient of 8 and an unknown value. Quotient is division. Now, the order definitely matters. Whatever's written first, I have to write first over an unknown number, or I can write it out this way. Okay, now less than is when we flip the order. Unless it's less than, you don't need to flip it. You can also flip more than, but it doesn't matter if you do addition differently, because 5 plus 2 is exactly the same answer as 2 plus 5. These are both 7. So if you get the order mixed up for addition or multiplication, it's not that important. But subtraction and division, it's extremely important that you write the order of the numbers in order. All right, the product of some number and 5. Some number and 5, product means multiplication. All right, so you could say x times 5, or anytime you see something like this with a variable and a whole number, multiply together, it's almost always going to be written in this order. Almost always, every single time, almost. All right, the sum of 11 and a number. Sum is addition, so 11 and a number. And I know I'm writing x's a lot, but you can literally write any number, or excuse me, any letter in the alphabet. The product of a number and 12. So either I could write x times 12, or since it's a number times a variable, almost always it's going to be written like this, 12x. A number more than 10. Now this is one where you technically are supposed to switch the order, so that you would write your number, your variable first, and then your 10, what's in the back goes to the front, So 10 plus x. So technically this is the best answer, but since it's addition, if you got the order backwards, it's not really going to be a big deal because you can flip the order of multiplication and addition and get the same answer. So for example, if that x was a 2, 10 plus 2 is the same as 2 plus 10. All right, 7 decreased by a number. So you must, this is subtraction, so you must write it exactly like it's written here. 7 comes first, minus an unknown number. There's your variable. 7 less than an unknown number. This is subtraction. I must throw what's in the front to the back and what's in the back to the front. So an unknown number, I can write any letter I want, minus 7. This is exactly what you have to have. If you put 7 minus a, that would be wrong. It's 7 less than a number, a minus 7. The product of 5 and the quantity, all right, here's quantity. It keeps all of this together. Quantity of, let's write that first, 40 minus a number. And then the product of 5 and all of that. And that's how you write it. You must write those parentheses. 3 less than what? 3 less than what? The sum of a number and 9. All right, so the sum of a number and 9. So a number plus 9. That's the sum of a number and 9. And then 3 less than that. So that would go to the back, and what's in the back comes to the front because less than is reverse order. The sum of 4 and the product of, the sum of 4 and the product of what? The product of some number and 8. So the sum of 4 and, so the sum of 4 and the product of some number and 8. That's what it looks like. A number to the power of 5 times 3. A number to the power of, a number to the power of 5 times 3. 5 times 3 is 15. A number to the power of 5 times 3. Oh, I'm saying it. Okay, let me start over. I'm sorry. I was like, wait a minute. A number to the power of 5 times 3. A power to a number to the power, a number to the power of 5, and then all of that times 3. So I could either write times 3 this way, or most of the time you would see it like that. Okay. Ooh, that one was a little tricky. All right, now you guys, I want you guys to practice, right, using word phrases to describe these. So for example, you could think a number divided by 6, the quotient of a number, and 6. That's pretty much it, right? Twice a number minus 7, or 7 less than 2 times a number. The product of 6 and a number. The product of 6 and a number, or 6 times x. All right, x less than 6, x less than 6, or 6 minus x. There's more than that, right? The quantity of x plus 4 divided by 6, or the quotient of x plus a number plus 4 divided by 6. And of course, there's different ways to say this, right? So we could say the 3 times the quantity, 40 minus x. 3 times the quantity, 40 minus x. Twice the quantity of x plus 9. Twice the quantity of x plus 9. The quotient of 4 and a number increased by 2. The quotient of 4 and a number increased by 2. Or twice x minus 9. Or you could say 9 less than 2 times a number. All right, so just some practice there. All right, in the term 7x, 7 is called the coefficient. Like terms are terms with the same variables raised to the same exponents. The coefficients do not have to be the same. All right, so also a constant is a number not multiplied by a variable. So all constants are like terms. For example, 5 and 3.2 and 1/2. All of those are constants. So those will all be considered like terms. All right, so let's talk about identifying like terms. We're looking for the same variable raised to the same exponent. So 5a, so technically if you don't see an exponent, it's a 1, okay? If it's anything other than 1, it'll be written like this 2 right here. So 5a would be a like term to negative 3a. Those are like terms. They have the same variables raised to the same exponent. All right, let's look at the second term. 3y squared is like 6y squared. Same variable, same exponent. Negative 5 is a constant. So negative 5 is like negative 3. Those are like terms. And then 3y is all by itself. It doesn't have a like term. There's no other terms like 3y. So now it says we're going to combine these like terms. So in other words, if I have 5 apples plus, or actually it says minus 3a. So let's start over. So we have 5a combined with minus 3a. So 5 apples, take away 3 apples. What do we have left? We have 2 apples. All right, the second one is a positive term, 3y combined with a positive, or excuse me, 3y squared combined with a 6y squared. Well, 3y squared plus 6y squared is 9y squared. The other, these constants are like terms, so it's like combining negative 5 and negative 3, which is negative 8. And we've just combined our like terms. All right, so I want you guys to practice. We'll do them together, and then on the next screen, I want you guys to practice without me first. So 7x plus 2x is 9x. We're adding those coefficients. All right, so 5x cubed is like 7x cubed. So 5x cubed plus 7x cubed is 12x cubed. And then we have 3y minus 2y. 3y minus 2y is positive 1y, or just positive y. And then this is a term that's not like the others, so it's just part of our answer. So this is all we can do once we've combined those like terms. All right, here we have 3a plus 5a. 3a plus 5a is 8a minus 2b. Here we have 1a plus 2a is 3a. 2b plus 1b is 3b. And then minus 2c is part of my answer. And then here we have 10x plus 5x. 10 plus 5 is 15x. And then negative 12b combined with negative 10b, same signs, add and keep, we get negative 22b. Now I want you guys, and now we're going to try our distributive property. So when you have distributive property, that means you multiply everything inside the parentheses by what's outside the parentheses. So we're going to multiply, and then we'll combine our like terms. So negative 2 times x is negative 2x. Negative 2 times y is negative 2y, plus 4 times 2x is 8x, and 4 times negative 3y is negative 12y. Now I'm going to combine my like terms. We have negative 2x plus 8x. Negative 2 plus 8 is 6x. And then negative 2y combined with negative 12. Negative 2 minus 12 is negative 14y. All right, you guys try and then watch the video and check your answers. All right, so we're going to bring over 5x plus 2 times y, 2 times a negative 3x minus 10x. Combine our like terms. 5x minus 6x is negative 1x. And then 2y minus 10. Oh, that's an x. Whoops. So we have, sorry about that. 5 minus 6 is negative 1, and negative 1 minus 10 is a negative 11x minus 2y. That's the answer right there. Okay. So then we're going to combine, or distribute, I should say. So negative times a negative is a positive. Negative 5 times 3y is negative 15y. Negative 5 times negative 6 is positive 30. And then when we combine like terms, we get 5x minus 15y plus 70. And then we're going to combine or distribute the 3d. So we have d plus 3 times 2 is 6d plus 3d times x is 3dx. And then we have a couple of like terms. So we're going to add 1d plus 6d, which is 7d. And then we have 3 dx minus 10 dx, which is negative 7 dx. And then the last one, we have a plus 3b times 5 is 15b. And then minus 3, a negative times a positive is a negative. So then it's negative 3ba or 3ab. Doesn't matter the order. Usually you put them in alphabetical order. All right, what are we going to combine? We have 1a plus 1a is 2a, and 2a minus 2a is 0. And then we have 15b. 15b, we're done with that one. And then we have negative 3ab plus 12ab. That would be positive 9ab. All right, you guys, that's a lot of stuff, right? A lot of stuff for sure. All right, so I hope that made sense to you. So let me know if you have any questions this week and I will help you with your work. Just let me know. Everybody have a great day.